attempt to read our learning goal that's got all kinds of big words in it over here? Who wants to do it? Kaden?
I can write algebraic equations that represent.
No, that's not equations.
Oh, expressions
Okay.
that represent patterns in the translation.
No, this is not translations. It's got a little, especially when I write it in cursive, it's kind of hard, isn't it? Ikea. Tessellations. So I can write algebraic expressions. Expressions don't have equal signs in them, so that's why we're not going to say equations. We're going to have just expressions. Algebraic means there's going to be a variable, at least one variable involved in it. And patterns, we've talked about we've been working with patterns. How many of you have done a tessellation before? Have you ever drawn a tessellation? Art class or anywhere? How about you guys did art tessellations in junior high art? Maybe some of you haven't had art yet?
I did at St. Kate's.
Pardon?
I did at St. Kate's.
You did it at St. Kate's when you were still, before you got to junior high then. Okay. Okay, so here is a tessellation right here. The first thing that we have here is this is what we consider a tessellation. So it says to find the algebraic expression for each of the visual patterns, complete the tables, and use them to help you find the patterns. So each set of colored stars, so we're looking at number 1, I'm reading right here. Be there with me, okay? Each set of colored stars makes up a ring in the pattern. The black star in the middle of the pattern does not count. That sounds like important information. Black star in the middle of the pattern does not count. We're going to ignore it, in other words, as part of the pattern. Start with the 5 stars in the center ring and then work outward. Okay, so we're going to take our highlighters and we are going to highlight the 5 stars that they're talking about. So remember, the star in the middle does not count. So take your highlighter and highlight this ring of stars. There's our first ring of stars. Okay, so now what we're going to do is we're going to count up how many stars are there. So close your highlighter up after you've highlighted that. And take your pencil and count how many stars do we have in that ring. So we will call that ring number 1. And how many stars does it have in it? It has 5 stars in it. So we're going to go down to the table and we're going to put 1 in our first box in the row for ring. And we say there are 5 stars. And notice I've said that we're going to let ring be represented by R. So if you need to make that better, if you can't see it very well on your paper, ring is going to be represented by R and stars is going to be represented by S. Okay? So now, the next ring of stars, are they darkened or are they lighter? They're lighter. So now let's not highlight those or we'll just have one very big colored picture, right? See if you can count the stars around our highlighted ring. How many stars are there around the highlighted ring? How many stars do you get? What do you get, Danny? 10? Anybody else get 10? Okay. Yep, there should be 10 stars in that one. So we're going to put in ring 2, in the second ring of stars, we get 10 of them. So you were supposed to be counting this ring. So put a pencil mark after so you know where you start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, the next ring, let's highlight that one again. Let's highlight the third ring so that we can clearly follow it around. And then cover up your highlighter and count the number of stars in that ring. Okay, how many did you get, Paikia? 15, she says. Okay, let's put that in our table and see if everybody agrees. After they're done counting. Do you agree there are 15 of them? and now count the last ring. Don't highlight it, just count it. Put a mark where you're starting so you know and you don't end up counting it twice. How many get, Wade? 20. Everybody agree with him? Get 20? Okay, are you seeing a pattern there? Besides the pattern of the stars, I mean, we can see that we have a nice pattern of stars. Tell me what the pattern is in this, going on in this table. Hayden, what do you think?
Just the top one's going by ones and then the bottom number of stars is going by stars.
Okay. So, yes, Wade?
X times 5.
Well, we don't have any X's because I called the ring R and the stars S, so which
R
one?
times 5.
R times 5. If you take the ring number times 5, you get the, so let's put that right here. If you take the ring number times 5, there's our algebraic expression that helps us get the number of stars. So they're asking us though for an algebraic equation. What did I say we have to include if we're going to make it into an equation? What has to be in an equation that's not in an expression? Wait. An equal sign. So we're going to make it into an equation. We're going to say, oh, the number of stars, S, is equal to what? R times 5. Our expression that says, here's how you can get the number of stars in a ring. Multiply the ring number by 5. So now it asks us this question. Suppose we could either keep drawing this pattern, or we could use our equation to figure out how many stars are there in the 8th ring of the pattern and show our work. Kaden, put your head up for me, please. Yes, you too, Cheyenne, thanks. Okay, so we're going to go S equals, we're going to write down our equation first. And where are we going to put this information in? Is that going in for S or for R? That's the ring number, so we're going to put it in for R. So 8 times 5. So what's our S equal? Harley? 40. 8 times 5 is 40. So the answer to the question is, how many stars are there in the 8th ring of the pattern? 40 stars. That'd be a lot of stars, right? Yeah. Okay. Questions? Okay, then it looks like you're moving on without me. Okay. Number 2. Read that to yourself. We're going to do something a little bit different this time with our highlighter, so don't jump ahead of me. Okay, tell me something that's really important in this one. Something that we have to take into account before we even try this problem. We have to make sure we pay attention to. In fact, circle it, underline it, something in the words that you read. Okay, Kaden, what?
The blank X at the center of this pattern does not count as a part of the pattern.
Now, the blank X at the center does not count. So what we're going to do with our highlighter this time is we're going to highlight that X that does not count. We're going to say, we are not going to pay any attention to that. Because now it says the first ring involves the 4 gray squares that go around the blank X, are colored in X. So we're going to go to our table and we're going to put for ring 1, there's how many squares? What did they say? The first ring involves the 4 gray squares that go around the blank X. So 1, 2, 3, 4, right? But then it tells us something else. What does it say for the next thing? Harley?
Got the black circles, the black square, the black square for the second one.
Okay, how many are there? Yeah, so it says the next ring has 8 black squares. So ring 2 has 8. It's already told us. So let's look to see what did they count the ones in between them? 1, 2, 3. So we're jumping over 4, 5, 6, 7, 8. I started down here. 1, 2, 3, 4, 5, 6, 7, 8. So ring 2 has 8 of them. Well, now we are going to figure out how many there are in ring 3. Will they be black or will they be just lightly shaded? Lightly shaded. So if we start counting them, we could start with this one. So 1, jump over, 2, 3. Go ahead, count those around. We're in the third ring right now. How many did you get? 12. 12. We should have gotten 12 of them. So what are we gonna do? We're gonna put ring 3 has 12 squares in our table, okay? So off to the side now, I want you to write the algebraic expression that gives the number of squares based on the rings. So what do we have? What could we do? So let's call the rings R again. Let's call the squares S. Give me an algebraic expression only. What do you have to do to the ring number to get the number of squares? Sarah? R times 4. So ring number times 4 is our algebraic expression that represents the pattern that's going on. So we would know what to do for rings as we keep making this. Anybody disagree? Challenge? Okay, write an equation now then. How would we write an equation using our pattern? What equation could we set up? Kate, let's set up this one. Sylvia?
S equals R times 4.
Okay, S equals R times 4. S being the what again? Oh, did I do that again? I'm good at that, aren't I? S equals R times 4. What does S stand for again? Number of squares. R stands for what ring number we're in, and we're going to multiply the ring number by 4. So now it says how many squares are there in the 11th ring of the pattern. So what kind of work would we show? How does our work start, first of all? Harley, how does our work start?
S equals R times 4.
Good job. S equals R times 4. Write our equation. Now what are we going to put? It's our next line that we're going to show. Sam?
S equals 12 times 4.
S equals 12 times 4. Because we want to know for the 12th ring,
That's 11.
11th ring, right? We want to know for the 11th ring, so we need to substitute an 11 here, not a 12. And what's 11 times 4, class? 44. So there are 44 squares that would need to be in the 11th ring of our pattern, of our tessellation. Okay, can anybody tell me, will there ever be an odd number of squares in the ring? No. Looks like we have 4, 8, 12, 44. Will it ever be an odd number? No, it won't. Okay. So anybody have any questions about this one at all? Because I'm setting you totally loose on your own for the next one. You decide what would make sense to highlight. Don't color the whole picture, I'm gonna tell you that. Okay, so you do the hexagon one. Read the problem and complete it. So go all the way through figuring out what would the algebraic expression be after you get your table filled out. Then what would the algebraic equation be? And lastly, how many would there be in the sixth ring of this pattern that has hexagons? And I will take a volunteer to come up, and one person can complete my table, finish my table. The other next person can write, you can complete the table and write the algebraic expression. Another person comes up and writes the equation, and then a last person comes up and figures, does the work for me. So, whenever you're ready, push me up, and I'm not gonna do it. So, finish the table and algebraic expression first. No, not equation, Cheyenne, I just want the algebraic expression off to the side. Okay, thanks. Okay, so she's calling the ring number R, apparently, which is totally cool. I will show that. Next person does the algebraic equation. The rest of you keep working if you're not done. So does that say H equals R times 6? Okay. So she's calling the number of hexagons, she's giving that an H value. Okay. Who wants to do the figuring, showing how much there are is in the sixth ring? Come on up, Wade, then, and show your work. Along with the answer, and those of you that done, just keep working, okay? Thank you, Wade. So, do we agree with all three parts of that got finished up for me up here? Everybody agree? Any part we want to challenge? Okay, tell me how many hexagons would be in the 10th ring? 60, right? 6 times the ring number. I know, but I'm just coming up with an extra one. So in the 10th ring there would be 60. In the 100th ring there would be 600. Yeah, so we can just keep, this pattern can just keep going. And all we do is every ring gets how many more hexagons? 6 more hexagons. Yeah, every ring gets 6 more hexagons. That's what's happening in our table here. As each ring, we just kept going up by 6. Okay, there's one more to do, right? We have start with the 4 octagons in the center of this pattern. So is anything left out this time?
No.
No. So let's highlight those. Let's highlight the start of our pattern. Where does it start? Okay, so what should we have for our variables this time? Should R be ring? Okay, and this time it's octagons, so what should we make? How about an O? Okay, so we'll have an O for our octagons. Make it small though, so it doesn't look like a 0. Okay, that's the problem with using always, it might look like a 0. So we make it lowercase, just like our little r is lowercase. Okay, so in ring 1, how many octagons are there? 4. Okay, don't highlight the next ring, just count, right? How many did you get in the second ring? 8, so did I. Predictions, how many there'll be in the third ring? 12, okay. Sure enough, I got 12, did you? Sure. So what would our algebraic expression be? First of all, what do we have to do to R to get the number of octagons? Ikea? Multiply by 4. 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. So that looks like our pattern. Multiply the ring number by 4. And the equation says to get the number of octagons in any ring, take the ring number times 4. Little o for octagons. Maybe we put a little curly Q up there at the top of it. It's got, it looks like a O instead of 0. Equals R times 4. Okay, figure out how many are in the 20th ring. How many octagons would be in the 20th ring? How many are there, class? 80 of them. There's the 20th ring times 4, so we say there are 80 octagons. And spelled correctly, it's right there for you. Don't be lazy. Octagon. And octagons are hard to draw, I think, so thank goodness we don't have to draw 80 octagons. Right? Okay. So, being able to write equations, algebraic expressions, and make it into equations or patterns. This is keep continuing to lead us into being able to do algebra. Okay, if you're done with your highlighters, let's have those